Okay, so today's lesson is going to be on measurement of segments and angles. This is going to be in 1.2 in your books. The objectives are to be able to measure segments, angles, to be able to classify angles by size, to name the parts of a degree, and to recognize congruent angles and segments. Okay, so for measuring segments, you can use a ruler or meter stick, or in your book it'll often be on a number line. For example, let's say we have segment AB and we wanted to know what the length of it is. You take the smallest point, in this case -3, and we want to know what this is. So what we don't know is that. So -3 plus this distance, which is going to be x, is going to end us up at 9. So -3 plus the distance from A to B equals 9. So all we have to do to find out what that distance is add 3 to both sides, and that's going to give us x equals 12. So in this case, the length of this segment is 12. Okay? Measuring segments really doesn't get that much harder than that. All right, next. Measuring and classifying angles. For the purpose of this section, the angles are going to have a measure greater than 0 but less than or equal to 180. So you can write it as a compound inequality like that if you want. When you classify an angle by size, they fall into one of 4 categories. We have acute angles, which look like this, obtuse angles, right angles, and straight angles. We'll get into the descriptors of those in just a second. Okay? So an acute angle has a measure greater than 0 but less than 90. Okay? A right angle has a measure of 90, only 90 degrees. An obtuse angle will have a measure greater than 90 but less than 180. And a straight angle has a measure of 180, and it forms a straight line. For example, if we wanted to put this and use some algebra here, and we said an acute angle is 3x plus 30. What are the restrictions on x? Because an acute angle, remember, has to be greater than 0 and less than 90. So we could write this as either a compound inequality where 3x plus 30 has to be greater than 0 or less than 90. If that gets a little bit too confusing to you, we can take it and break it down into its 2 parts. So we have one part, which is this here, and that's one equation. 0 is less than 3x plus 30. And we solve for that inequality. So subtract 30 from both sides, okay, which will give you 0, or not 0, -30 is less than 3x, and then you have to divide by 3, which gives you -10. So x has to be greater than -10, and then you have this other part here. So 3x plus 30 has to be less than 90. So again, you subtract 30. Same first step for both parts. Which gives you 3x is less than 60. Divide by 3. Which will give you x is less than 20. So the restrictions are, you can write it as -10 is less than x, which is less than 20. Or you could say x must be in between -10 and 20. So however you want to do it, as long as you know that these two are the same thing here. This could be an answer or this could be an answer. If you want to use words, if you want to use the algebraic inequality, that's fine too. Okay. Moving right along into degrees. I know we're moving kind of fast, but the good thing about these videos is you can pause it, you can take your notes, you're good. Okay, so like the hours of a day are divided into 60 minutes, which are then divided into 60 seconds, which are, make up an hour. Each degree of an angle is divided into 60 minutes, and then each minute of an angle is divided into 60 seconds. Okay, so for example, if I wanted to convert 87.5 degrees to minutes and, well, not seconds, but just minutes, 87 degrees, 30 minutes. This symbol means minutes. If I wanted to convert 60.4 degrees into minutes, 60 degrees, 24 minutes. Same thing with 90 degrees. 89 minutes, 89 degrees, 60 minutes. Because 60 minutes equals 1 degree, it would just be a matter of taking that 1 degree and breaking it down into minutes. And likewise, 180 degrees, if I wanted to break that down into minutes and seconds, I'd have 179 degrees, take that 1 extra degree, break it down into minutes, which are 60 minutes, but then I want to break it down into seconds, so I take 1 of those minutes and break it down into 60 seconds. Now, how do you do this? Well, let's say we wanted to change 41 2/5 degrees to degrees and minutes. So the 41, we know that's not going to change. Okay, that 2/5, we want that to be minutes. So how do we do that? Well, we can write a ratio. 2 over 5 is the same there as 60 minutes, and we need to figure out what this part is here. And that's going to give us this. So we can, here is where you can cross multiply and divide. 60 times 2 equals 120. And then 120 divided by 5 equals 24. So it would be 41 degrees, 24 minutes. Okay, now let's say we have a more complex problem like this here. Given that AB and C is a right angle, and the measure of angle ABD is 67 degrees, 51 minutes, 37 seconds, find DBC. Well, we know that ABC is a right angle, and we know that we have part of that right angle's measurement here. Now we just need to find this part. Now, since ABD is in degrees, minutes, and seconds, we need to write that as that 90 degrees, that total, we need to write that in degrees, minutes, and seconds. So that would be 89 degrees, 59 minutes, 60 seconds. Because remember, this is the same as 1 minute, which when you add it to this would be the same as 1 degree. And subtract that. And you just subtract like normal, nothing fancy. Break it down into the parts though. So, 60 minus 37 is 23. Oh, forgot to put that there. 59 minus 57 is 2. And 89 minus 67 is 22. So our answer would be 22 degrees, 2 minutes, 23 seconds. That would give us our angle of DBC. And then if I wanted to change this to just degrees, well, we know that 45 minutes is out of 60. Okay? And if we want to change it to degrees and we want to leave it as a fraction, we can just take this and reduce it. So let's find a number that goes into both of these. Well, I think the biggest one would be 15. 15 goes into 45 3 times. 15 goes into 60 4 times. So we could write that as 60 degrees because that doesn't change. Oop, not 60 degrees. 60 3/4 degrees. Because when we have it as just degrees, everything, all the numbers are to the left of the degree symbol. Okay? So that would be that answer. And now, congruent angles and segments. In the diagram above, angles A, B, and C are all congruent. We know this because they're all 40 degrees. Congruent means they're the same. So we write it like this. Angle A is congruent to angle B, which is congruent to angle C. Okay, congruent angles all have the same measure. So this means congruent. Okay, and don't forget to put your angle sign in front. Okay. Now, like angles, congruent segments are segments with the same length. So let's say I have these 3 segments. All of them are 5 centimeters long. So how would we write that? Take a minute, pause me, see if you can figure it out. Okay, what you should have is segment AB, don't forget about the line above, is congruent to segment CD, is congruent to segment EF. Okay, so that's how you would express that. Now, tick marks are often used to indicate congruence of angles and or segments. So in the diagram below, what are the three pairs of congruent parts? Well, I see two tick marks here. So segment AB and CD are congruent because they have the same tick mark. So I could say segment AB is congruent to segment CD. Let's see what else, because there are three pairs. So let's look for another circle. I don't see another circle. And a tick mark doesn't have to just be a little line. It can be anything. It could be a shape like this, or an angle, with a line through it like this, or just by itself. Here, I've got an angle, but I don't see another double angle line. So let's see, that one didn't have a congruent thing. This one doesn't. Here, these two triangles share a segment, so I can say segment EF is congruent to segment IH. Now notice it's not the whole triangle because I don't know anything about these two sides here. There's no hash marks, there's no tick marks, so I don't know if they're congruent or not. I can only go by what I'm given. Okay? But I also see an angle with one hash mark here and here. So I can say angle FGE is congruent to angle IJH. Now, if you wanted a shorter way of doing it, you could say angle G is congruent to angle J. Now, why can I do that? I can do it because the vertex G is a vertex for only one angle. Remember, like the lesson yesterday, if it's a vertex for more than one angle, you can't use it. But G and J, vertex is for only one angle, so you can shorten it like that if you like. Okay, that'll do it. If you have any questions, ask tomorrow in class.